Hello everybody. Today we will be going over lab activity number 7.8. So we're going to be talking about some C strings today. So not only are we going to be talking about C strings, but we're actually going to be writing some of our own. So today we are going to do just that, and we're going to implement some string functions. For example, we will implement our own version of string length, and then we will do some other functions that are similar to some of these other string library functions. So to start, it's important to get this out there. For this activity, we aren't allowed to use the built-in string functions for somewhat obvious reasons. And yes, so let's go ahead and look at what our program will look like when we run it. So we're just going to enter a string. So in this example, we have cat. And then after we're prompted and enter our input, the program will output our string's length based on the function that we write. And then we will go ahead and the computer will show us what our string looks like without any vowels in it. And then it's going to ask for some more input, and then we will just concatenate a duplicate of the string without vowels onto itself for however many number of times. If we want to say the word is hello, then we will see that hello has a length of 5 as we expect, and then without any vowels you're missing E and O. And let's say we want to make 4 duplicates, then you just get that 4 times. So a key thing to think about here before we proceed to writing these functions is that for the number of duplicates we want to make includes the original. I know that's a bit misleading, but so if we enter that we want to make 4 duplicates, then there will be 4 instances of the original string without vowels total. So before we go ahead and jump into writing some of these functions, let's take a look at main and see what's going on here. So we have these two strings. We have user input, which presumably is what we are going to give to the program, and then we have this line length constant. So you want to go ahead and look, and we can see that line length is 81. So that's just kind of that standard default string length for C strings. And we also have this new string character array with the same amount of space allocated for it. Here in main, we are just taking care of making sure that there's a null terminator character somewhere in our new string. This is going to contain the string after we manipulate it a little bit. And we could just put one at the end and that would be fine, but just to be safe, we just populate the entire thing with null terminator characters. So then we're going to go ahead and accept our input. We prompt for it here, receive it in right there. And then we are going to display the results from our unwritten function. So it's going to be called myStringLength, mystrlen, however you want to pronounce that. And it's just going to take the user input as an argument. And so here we've got most of our main code commented out. We can uncomment it here so we can take a look and analyze it. So our second function will be called removeVowels, and we're just going to remove any vowels from the string. Yes, so pretty straightforward there. And then our third function, we're going to duplicate the string. So now it's important to kind of see how these functions are being used in our main program here, and that will help us figure out what return type we will need and what parameters to define our functions with. So for my string length, you can see it's being used in a print statement, so it probably has a return value. And as we might expect, it has an integer return value that just represents the total length of the string. So that will help us write that function header. And then we will look at removeVowels. And removeVowels just takes in the new string, the string we want to insert the characters which are not vowels into. And then it's going to also take in user input, so it can figure out what needs to get inserted into that new string. Since this function isn't being assigned to a variable or used in a print statement, we can probably assume that this is best to be a void function. And same with duplicated string down here, or duplicate string down here. We're just going to take in the new string and then how many total instances of the string we want to exist in the duplicate. So now that we have that taken care of, we can go ahead and define or declare our function prototypes. So since we've already seen the parameters that we need and the return types that we're looking for, I'm just going to go ahead and put them in here for us. Okay, so now that we've got these prototypes up here, we can go ahead and define them down below. Of course, we could just define them right here and get rid of the declaration, but I just want to include this in one of my lab solutions so you guys can see how it kind of looks. It's good practice in general, especially as programs get larger, to declare all of your functions at the top, and then have your main, and then have your functions defined down below main. So the first function we want to work on is my string length, right? So again, whenever we're writing functions, we want to go ahead and make function headers, right? We want people to be able to read our code and know what's going on. So let's do that. So fairly simple here. We just have our function name, my string length, and then we have a description regarding its parameters and return types. So we say, okay, my string length returns an integer representing the length of the string user input. And then we can go ahead and grab our header and start defining our function. So this one is not too complicated, guys. We just want to loop over the string, and then for each character that we see that is not a null character, we want to increase our length. Okay, guys, so real quickly before we go ahead and write this function, I just want to put it out there that there is like so many ways to implement all of these C-string functions. Um, there's lots of compact syntax, but typically that's more difficult to understand at an entry level, so we're just going to go with the most intuitive and straightforward way to implement these. So as far as my string length goes, we can just make a for loop, right? And we don't have to, we could use a while loop, but it's just very easy to understand this way. So we know we're going to be returning an integer representing our string length, so we can just go ahead and declare that, string length, initialize that to 0, and then we're just going to loop over each character. Now what is the stopping condition, right? So we don't know what the length of user input is. So how are we supposed to know when to stop? I mean, you guys can see my GitHub suggestions here. But yeah, so when we reach a null terminator character in a C string, that's how we know the string has ended. So we're just going to go ahead and loop until that is encountered, and then we are going to return that string length afterwards. So let's step through a little example just to convince ourselves that this actually works. So here we have an example of the string cat, just like in the introductory sample output. So here I have our indices for our character array. You can see the null terminators at the end here. And then here we are counting our string length as we go through. So we're going to start with I equal to 0. And then so we're going to look at the character at the first position in user input, which is C. So since C is not the null terminator, we will go ahead and enter the loop and increment string length. Okay, so now we increment I since this is finished executing, and so I is 1. User input at 1 is A, and so that is not the null terminator, so we increment string length to 2. And then we go ahead again, and then I will now be 2, and we see that user input at 2 is T, and T is not equal to the null terminator, so we're going to increment string length, and then we're going to increment I again because this last iteration of the for loop has executed, and so now I is equal to 3. And if we look at user input at 3, we will see that that is in fact equal to the null terminator. So we will not enter the for loop, and we will just return string length. So that is all there is for this function. Here again, we'll just have our function name. I have some nice white space to make this all legible down here. And then our description says we're remove vowels removes all vowels from the string user input, this character array here, and we're putting the resulting string into new string. There are more technical ways you can describe it, but this works for our purposes. Okay, so how do we do this? So intuitively, we just want to go ahead and think about, okay, so we're removing vowels from some word. So if we're looking at our cat example again, we can see, okay, we know that A is a vowel, so we'll want to remove A. Okay, so then we can just loop over our string, user input, and we can only include it, we can only append it to new string if that character is not a vowel. So we encounter C, we'll see, okay, C is not a vowel, so then we'll include that in new string. And A is a vowel, so we don't want to include that, right? And so let's go ahead and get started with this. So just like in the last function, we will have our for loop. We'll just initialize a counter and go until we reach a null terminating character. So now how do we check if something is a vowel? These GitHub suggestions really need to stop killing the instructional value here. But yeah, so we can just kind of I mean, it's not exactly, it's not hard coding it, but we can just brute force check if each character is a vowel. There's only a few vowels. There's 6 of them, right? So we can just say, okay, if it's not any vowel, then we will go ahead and add it to the new string. So this will be a rather long conditional. So I'll just paste that in here now. Let's format that. Okay, awesome. So yeah, so if the character at the current position in user input is equal to A, E, I, O, or U, then this will not execute, and we will just go on to the next one. So what if we do this? If we say that new string at position I is equal to, oh wait, this isn't right. Let's just do that. Okay, cool. So if we say that new string at position I is equal to user input at position I, then it seems like it would just copy over everything exactly how we want, right? Well, not quite. So let's go ahead and step through our cat example. So we see that C is not a vowel. So in the first iteration of the loop, we will go ahead and say, okay, new string at I, which is 0, is equal to user input at I, which is still 0. So here we can see, okay, there's no problem. C is now inserted into into new string. So now we will continue on to A. So A is a vowel, right? So since A is a vowel, this will not execute. So now we go on to the next iteration of the loop. So I is now equal to 2, right? And so we'll say, okay, T is not a vowel, so then we will go ahead and enter this. But wait, there's a problem, because now our new string looks like this. So this is our user string, and our new string has C. And here we don't know what's here, right? Because we skipped over inserting anything into the string at that iteration. So whatever. Oh, well, actually, we know that there's a null terminator because we initialized the entire string to have null terminators at the beginning of the main program. So here there's a null terminating character, which signals the end of a string. So clearly that's not what we want, but let's continue looking through our example here. So we're at 2, we're at index 2, so then we will say new string at 2 is going to be equal to t. But this isn't going to behave how we want, because C++ and C recognizes a null terminator as the end of a string. So this together is not a string. So we need to do something about skipping these spaces. So what we can do is we can just introduce another counter, and we can have that only be incremented if we've inserted a new character into new string. So we can just say int j, make sure to initialize this to 0. If you don't, you will have some unfavorable behavior with your out of bounds index. And here we can just say, okay, we will instead say new string at j is equal to user input at I. So we're still accessing the user input one by one. But then we will just increment j instead of for each iteration, only when we are encountering a constant, or a consonant. So when we are not encountering a vowel, then we will increment this counter, and so the string will be populated properly, right? So here, if we encounter, so we skip A and we go to T, so J is still going to be 1 after we inserted T, right? But then we skip A, and J is still 1. So then we're on I equals 2, J equals 1, and so new string at 1 is going to be equal to T. So we get what we want. And remember, we've already populated new string with all null terminator characters. So we don't have to worry about including a null terminator at the end, because we already know that everything all the way up to index 80 is populated with null terminators. So this takes care of our remove vowels function. So now, lastly, but certainly not least, we will have to do our duplicate string function. So here, again, we're just making our function header with our function name and then a short description. So we have that duplicate string is going to duplicate the current contents of new string, how many total times, storing the result in new string. So the language is a bit misleading and perhaps a bit inaccurate here. So we're not actually duplicating the string how many total times. There are just going to be how many total number of the original new string in the duplicate string. Um, so we will see exactly what that means as we go ahead and continue to develop this. So first, we want to allow the user to specify how many times they can duplicate the new string. But for our for the sake of our implementation and our problem-solving strategy, we will just try to break this down and think about, okay, so if we just wanted to append it one time, how would we do that? So you would want a loop, right? So let's say we have another standard for loop, and we're just going to loop over the original string, and we're going to insert the character of new string onto the end of it. So if the new string is ct, and we want to duplicate the string, we say, okay, well, we want to start at index 2. This is where we want to insert the first character of new string. And so we can think, okay, so how do we get this number in an algorithmic way? Well, we've already written a function that calculates the length of a string, and we know that since we have a zero-based indexing system, that the length will always be 1 greater than the last character or the last object in any container. So we can say that the length of the string, of new string, is going to be our starting position for the characters we want to insert into the duplicate string. So we're just going to go ahead and write a loop here. But first, we're going to want to use our freshly written myStringLength function and assign a variable to that value. So we're going to use this to figure out where to start inserting characters into our array. Sorry about the short delay. I've just disabled GitHub Copilot so that we can try to build some anticipation of how we're going to implement these functions. And so yeah, so we want to go ahead and loop over new string. And we could just loop over it the same way we have been. We can just say, okay, until we encounter a null terminator here. But since we have it, we might as well use the string length. And we can say, okay, well, we want to start inserting characters at the length, right? So we want to say, for the first character in the duplicate after the initial new string, we'll say that we want that character to contain the first character of new string. I know it's a lot of word garbage here, but we will do new string length, right? Yes, new string length. And so this is where we'll want our very first character to have the value of new string at 0, right? But then to go ahead and extend this to the rest of the characters in the string, we will just add on our index. So we're just doing it how we would normally populate a string, except we're adding on the offset of new string length. So we will add I here, and then we will assign that with the character at I for new string, right? So in our example here, we're saying, okay, let's add on to new string the first character, right? So when I is equal to 0, we're saying, okay, at index 2, which is the length of new string, as you can see, at index 2, let's add the first character of new string, which is C. And then at index 3, let's add the second character, which is T. And then we'll keep doing this until, well, I suppose for this first iteration, we're just going to do it one time. So now that begs the question, okay, so how do we extend this to how many total times? Well, we know how to do it once, and we just want to do one operation a fixed number of times. So for loops are perfect for this, so we will just go ahead and wrap a loop around this entire thing here, right? And so we will just loop how many total times over this expression. So here I've gone ahead and change the index for the inner loop just to go with the standard I, J, K, so on convention. And for the outer loop, notice we're starting at 1 here. Now why do we do that? We do that because of the semantics of how the prompt wants us to write the program, right? So a good keyword here is our parameter how many total. So this is how many total instances of newString should appear in the duplicated version of newString. So if we started at 0, then we would duplicate newString that many times, which means there would be an extra instance of newString, which is undesirable for this specific use case. So the way that we take care of each extra iteration, because you might say, oh, well, before when we only had the plus j, it would just keep overwriting the second duplicate over here. So to remedy this, we can just multiply by the outer loop's offset. And since we start at 1, this makes things very convenient for us because we won't have this issue where we go over the first string again. So we multiply by the outer loop's index, and that will effectively increase the offset by some. So I is going to be however many duplicates precede the one that we want to add on to, right? So for example, if we are on the third duplicate here, then we would have that this loop has already executed 1 time. So then I is equal to 2. And so since I is equal to 2, we'll take new string length times 2. Okay, so string length is 2, times 2 is 4, right? So that's the index that we're going to start at. And then we're going to add j to that, right? So this is our index 4, and this is where we're going to start adding our extra duplicate of new string. And then we're just adding j like how we were before. If it makes you more comfortable, you can include parentheses around the multiplication, but computers know how the order of operations work, and you'll just be able to multiply this first and then add this other offset afterwards, right? So this looks pretty good, right? So this helps us go ahead and duplicate our string, right? And this would be fine on its own. We could leave it like this, but we can only leave it like this because newString has already been populated with a ton of null terminating characters. Let's just include how we would want to add a null terminator character at the end in case we didn't populate the whole thing with nulls. For whatever reason, that might not always be possible. So here we're just going to say, okay, so let's say we've just finished the third instance. Imagine there's another CT here. The third instance of our duplicate in newString. So then, if that were the case, then we would have that. So new string length is equal to 2, right? So j would be equal to 1 at the end of this loop. So j is equal to 1. I would be equal to 2. And so here, let's actually just go ahead and illustrate this. So imagine we have some garbage here, and we want to make sure it's a null terminator. So to include our null terminator at the end of the string, we can just say, okay, well, we know there's how many total instances of the string, and we know that the length of a string will always be 1 after the last character. So we can just go ahead and access that position after we're done with our nested loop. And we can say new string at how many total times new string length is equal to our null terminator here. And so if we look at our example, we want to include our null terminator at position 6. We know that there are 3 total instances of the original new string. So there's CT 3 times. So we have 3 times 2 is the length. So 3 times 2 gives us 6. And 6, you can see, is the position for which we want to include our null terminator character. So that takes care of that. And now we have written all of our cstring functions. So this stuff can be kind of tricky, guys. I would say that the most important thing to keep in mind here when you're writing cstring functions is to not forget about the null terminating character. It can be really tricky and give some very unexpected output if we're not keeping our eyes out for stuff like that. So just to recap, we've went over how to go ahead and declare our functions at the top and how this is kind of a standard convention for larger programs, and then define them below main. We've analyzed a simple prompt, and we have implemented some functions as requested. So I hope this video is helpful for you guys, and I will see you next time.